For the second part, maybe we're given an equation with a logarithm in some of the terms, but not in all of them. So I have a logarithm here, but I have a number that's all by itself. Or a log expression here, but I do have at least one term that's a number all by itself with no logs. Then instead of using our one-to-oneness of logs, we're going to think back a couple of sections when we first learned about logarithms, when we found out that log base b of x equals y means the same thing as b to the y power is equal to x. In section like 4.3 or something, we went back and forth between logarithmic form and exponential form of our expressions. And while your book will explain it just a little bit different than this, this is really what we're doing here. So if log base 2 of x equals 3, in fact we probably did that example on the board the day we talked about section 4.3. We know the base is 2, the exponent is 3, and 2 to the third is going to be equal to x. We clean up the arithmetic and we're done. After we check and make sure that 8 is in the domain of that function, which it is. Over here we say the base to the exponent 2 is equal to the stuff inside, x minus 1. So if 9 equals x minus 1, then x has to be equal to 10. And if I take that 10 back to the expression and plug it in, 10 minus 1 is 9. That's an acceptable solution for our equations. So logs in some of the terms, but not all of the terms. We're going to think back to what we learned in our first section on logarithms, and we're going to think about turning the equation that we're given and putting it into exponential form instead of the logarithmic form that we started with. Now, just like what we did on the last video, if we have sums and differences, log base 5 of x minus 4 plus log base 5 of x is equal to 1, then we don't like to have a sum here. We need to combine them into a single term, and we know that sums go back together as products. There should be a minus, but I can't get to my minus sign. X squared minus 4x. Then, since I have logs in some terms, but not in all of the terms, the next step is to go to exponential form. 5 is the base, 1 is the exponent, and 5 to the first equals x squared minus 4x. Any quadratic equation that you have from the assignment that I give out of the book, all of them will factor. You don't have to use the quadratic formula there. You could complete the square if you wanted to, or you could use the quadratic formula if you want, but all of them will factor once you put them together, if you put them together the right way, and then take the right steps from there. Now if we go back and check our domain, 5 minus 4 is 1, which is positive. 5 is positive, so I know 5 is an acceptable answer here. But if I plug in negative 1 for x in either place, I'm going to have a negative number there with my logarithm, and I know I cannot take the log of a negative number, which means 5 is my only solution to this problem. Let's do one more. Maybe I'm given, my pen doesn't like to go where I want it to. Maybe I'm given log base 3 of 10 minus x minus 1 equals log base 3 of x plus 2. Make sure I copy that right out of my book. Yes. Alright, now we notice first of all, when we scan the problem, we have logs in some of the terms, but we do not have logs in all of the terms. So our goal is to get all of the terms with logs in them on one side of the equal sign, and all of the terms without a log in it on the other side of the equal sign. And we do that like any other algebraic problem that we do. We use addition and subtraction to move our terms initially. So I'll leave my log base 3 of 10 minus x. I'm going to subtract log base 3 of x plus 2 to the other side. I'm also, hopefully this doesn't screw anybody up, but in the same step, I'm going to add the 1 to both sides. So the 1 moves to the right, this log term moves to the left. Now that they're on the same side, I want to combine all of my log terms into a single log term. And in this case, we have a minus sign in between, which means instead of a product, I'm now going to create a quotient from those two terms. When I have log base b of stuff equals y, now I can go to my exponential form. The base is 3 to the first power equals the stuff inside, which is this ratio. In order to clear my fractions, I multiply both sides by the denominator, x plus 2. I can distribute, solve for x, no quadratic here, just a linear equation. Add x to both sides, subtract 6 from both sides, x equals 1. Now I always have to check. We can't assume that just because we only have one answer here that it's got to work. If I come up to my logarithm terms, 1 plus 2 is 3. Log of 3 is allowed. 10 minus 1 is 9. Log of 9 is allowed. And the main thing I'm checking here is to make sure that I have something in my domain. Of course, you could plug it in and do the arithmetic and make sure that your solution works. But if we trust our work through to this step, then all I have to do is make sure that this solution here is a solution to my original equation.